Hey guys, welcome to Lead Programmer. Today we are going to look at the problem product of array except self. So essentially we have an array of numbers and we have to essentially find the product of all the elements of the array except self. So the index corresponding to 1 should essentially have the product of the other elements except itself. So 4 into 3 into 2, which is 24. Similarly, for index 1, the product should be 4 into 3 into 1, which is 12. Similarly, for the index 2, we should have 4 into 2 into 1, which is 8. And lastly, for index 3, it should be 3 into 2 into 1, which is 6. Now, also note one interesting thing. If there is a 0 present, then essentially the index corresponding to 0 has the product of the rest of the numbers, and all other elements would be 0, which makes sense because the product of this highlighted element would be the product of the rest, and same for all. So it'll be 0 for the rest except self. Now imagine if there are two zeros at any two locations in the array. In that case, all the elements of that array would be 0, because if we do because in each of the scenarios we will account for at least one of those zeros, thereby resulting in an array with all the zeros. If you're still confused about it, try writing it down. Try writing an array with two zeros and try calculating it for each and every element. All the elements would be 0. And the same thing will apply for an array with three zeros, four zeros, and so on. All the elements would be 0. So as you can see, we have three cases. One case which is normal without any zeros, second case is with one zeros, and the third case is with two or more zeros. Awesome. So one thing we can see is if there are no zeros, then pretty simple, right? Why don't we just find the product of all the elements? Now if we find the product of all the elements, then the product corresponding to this index would be that product divided by 1. The product corresponding to this index will be that product divided by 2. For example, the product of all the elements here is 24. So 24 divided by 1 is 24, 24 divided by 2 is 12, 24 divided by 3 is 8, 24 divided by 4 is 6. So that'll work for all the cases where the array does not have a 0. Now, if the array has a 0, then again, calculate the product of all the elements except that 0. So let's see, 3 into minus 3 is negative 9. Negative 9 into 1 is negative 9. Negative 9 into negative 1 is 9. And that's the product that we put at the index corresponding to 0. And if there are two or more zeros, then we know we just return an array with all zeros. Awesome. So now that that's established, let's quickly write some code. So we essentially have an output array. Let's just name it output for now. You can probably have a better name. Also, uh, let's start then. Let's have a for loop. So that essentially runs from 0 to n minus 1, where n is the size of nums, which is essentially calculated by len of nums. And we essentially just want to find the product. Let's name it prod. So let's define it here. Prod equals 1. And prod would essentially be prod into nums at I. So this is a shorthand notation for prod equals prod into nums at I. We can write like that. But I want to do more with the loop. Rather than only calculating the product, I also want to calculate how many zeros are there, right? It's better to keep optimizing as we go. So now that we know that we also want to determine the number of zeros, let's just have a variable to store that. So let's say number of zeros defaulted to 0, and we can do a simple check. If nums at I is 0, then we can have a number of zeros equals number of zeros plus 1, which I'm going to do using a shorthand notation like this. Else, I just find the product as it is. There you go. So we have the number of zeros as well. Awesome. Now, let's come to various cases. So the first case would be if the number of zeros is greater than equal to 2, or 2 or more, then essentially you can say you can just return an array of zeros of length len of nums, right? So the way to do that in Python is using this notation where it's 0 repeated len of nums times. And a quick Google search will also help you figure it out for other languages. And we return the output. Beautiful. Now, coming to the case where number of zeros is exactly 1. In that case, note we have the product. We need the index at which 0 occurs, because the element at that index would be equal to prod, which is the product of the rest. So in order to do that, let's optimize further. Rather than calculating it again, or rather than having another for loop there, why not just have a variable which stores 0 index. Let's just initialize it to 0 for now. And since we're already going through the loop here, why not just do it here? So essentially the 0 index variable stores the last occurrence of 0, but we are going to use 0 index only for the case where number of zeros is 1, which essentially gives us the index of that 0, right? So that said, we can essentially copy the stuff from here. Probably you can optimize it further, but here is just an idea to get you guys started. So we have the output here, and we need the output at the 0 index to be equal to prod, as discussed. Awesome. And for the rest of the cases, so if we didn't return in these two iterations, then we would execute this for loop here, which essentially ends. So the logic that we discussed, basically the product of all the elements divided by the current index, the number at the current index, right? So here it'll be the integer division of prod divided by num. The reason I'm typecasting it to int is because the expected output is, let's say, for example, 12 and not 12.0. If we just do prod by num in Python, it would return 12.0, but we wanted to return an integer, and that's why we have to typecast it to an integer. So there you go. Now that we have generated that array, we just return output. And there you go. That's the solution. So please subscribe for more videos. Please like this video, share it. See you soon.